Hi guys, my name is Commander from the ECE23 and I'm here to present about NBDS. First, what is NBDS? NBDS are natural sampled BD switching single-sided modulation is a simple approach to devise the DFS expression for NBDS is by simple superposition. Since NBDS can be synthesized by a 180-degree phase shift of the modulating signal without opposing modulator. F over NBDS raised to T equals to F N ADS raised to T minus F N ADS multiplied by pi raised to T over 2. Subsequently, what is needed is a general expression for an ADS with the phase shift modulating signal. The individual harmonic components are identified to be IM component MX plus minus NY, amplitude 2J and M pi M over M pi multiplied to sine 2n over 2. By comparing NADS and NBDS, HES plus different importance difference are observed. The determining IM components MX plus minus NY are close to linearly J times X dependent on the modulation index at the lower output levels. The HES surfaces shows very pleasant spectral characteristics at the lower output level, and all high frequency components disappear at idle. This is very important advantage of NBDS, whereas all harmonic of the carrier were present in NADS, especially the odd harmonics. They are not presented in NBDS at all. All IM components MX plus minus NY with even N are eliminated, meaning that the spectrum only contains half of the components compared to NADS. This causes the stupid nature of the HES plot. The maximal IM component amplitude are lower than in NADS as a consequence of the synthesis of 3 switching levels. Advantages of NBDS: sudden degradation and incompatible with existing analog facilities. Second, offers most promise for dynamic control. Third, wide control to bandwidth. Fourth is high frequency switching components. Fifth is in particular for low or idle input signals, the output contains very little high frequency energy. The disadvantages of NBDS: due to changing width of the pulses, variation and transmission power is also noticed. More bandwidth requirement in case of NBDS is somewhat larger than other NPWM. Comparing the common mode and differential mode. Common mode, the signal flows through the two lines in the same direction and phase. When applying the right hand thumb, roll the magnetic fields associated with common mode signal might be opposite to each other. Common mode signal find a return path through the common ground. Parasitic capacitance between a circuit component and between the component and ground are the leading cause of common mode noise in a circuit. Parasitic inductance exacerbates the generation of common mode interference in circuit. The differential mode. This signal corresponds to differential mode signals. Differential mode noise or interference in electrical equipment is measured between the line-to-line voltage and line current. This noise is transmitted through the input lines to the utility system. The stray capacitance between the circuit components and the magnetic coupling between the circuit can be generated in generate differential mode noise. This is the example of 8 forms of NBTS. Summary: naturally sampled pulse width modulation, or N is PWM, is most favorable form of modulation because natural sampling does not introduce distortion or delayed response. Number 2. Two types of single-sided modulation: NBTS, natural sample BD, single-sided modulation, and NADS, natural sampling AD, single-sided